In a 3-wire single-phase circuit supplying power to a 3-wire utilization equipment, the ground and neutral conductor, identified as white or gray, must not be used as a current-carrying conductor for anything other than the connected utilization equipment according to the 2005 National Electrical Code, specifically Section 310.15b3. There are exceptions as permitted in subsections B, C, and D. Subsection D pertains to multi-wire branch circuits, subsection C to feeder taps, and subsection D to services. Under the 2005 National Electrical Code, in New York City, the neutral counts as a current-carrying conductor on a 3-wire single-phase circuit supplying power to a 3-wire utilization equipment. If a project was filed under the 2002 National Electrical Code, compliance with that edition is necessary, particularly as it relates to the specific circuit. The 2002 National Electrical Code, Section 310.15b3, states that neutral conductors shall not be used for the purpose of carrying unbalanced loads from 2-wire branch circuits. Section 310.15b4 outlines exceptions as permitted in subsections A, B, C, and D. Subsection applies where the circuit supplies only single-phase utilization equipment connected between the grounded neutral and one ungrounded conductor. Subsection B addresses multi-wire branch circuits. Subsection C concerns feeder taps as covered in Section 240.21, and subsection D deals with service conductors as covered in Section 230.42. Therefore, according to the 2002 National Electrical Code, if the circuit supplies only single-phase utilization equipment connected between the grounded neutral and one ungrounded conductor, the neutral conductor can be used as a current-carrying conductor. To elaborate on multi-wire branch circuits, it is important to understand their configuration and purpose. A multi-wire branch circuit consists of 2 or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits are commonly used to provide both 120 volts and 240 volts from a single circuit in a residential setting. For example, in a 120 volt/240 volt system, 2 ungrounded conductors each carry 120 volts to the neutral and 240 volts between them. The neutral conductor in a multi-wire branch circuit is permitted to carry the unbalanced load, which is the difference in current between the 2 ungrounded conductors. However, it is crucial to ensure that the neutral conductor is properly sized to handle the maximum unbalanced load to prevent overheating. Regarding feeder taps, the National Electrical Code allows for tapping a feeder to supply power to a smaller load under specific conditions. These conditions are outlined in Section 240.21 of the National Electrical Code. The length of the tap conductor is limited, and it must be protected from overcurrent at its point of supply. The purpose of feeder taps is to provide a convenient way to supply power to a load without having to run a separate feeder from the main panel. There are specific requirements for the size of the tap conductor relative to the size of the feeder conductor, as well as the length of the tap conductor. Concerning service conductors, these are the conductors that bring power from the utility company to the building service equipment. The National Electrical Code, specifically Section 230, covers the requirements for service conductors. These requirements include the size of the service conductors, the type of insulation, and the method of installation. Service conductors must be properly protected from physical damage and must be of sufficient size to carry the load served. The neutral conductor in a service entrance is typically grounded to the earth to provide a path for fault current. Now, focusing on single-phase utilization equipment connected between the grounded neutral and one ungrounded conductor, this configuration is common for many appliances and devices found in residential and commercial settings. For example, a standard 120 volts lighting fixture or receptacle is connected between the grounded neutral and one ungrounded conductor. In this case, the neutral conductor carries the same amount of current as the ungrounded conductor, as it is a simple series circuit. However, it is essential to ensure that the neutral conductor is properly sized to handle the current. When dealing with the National Electrical Code, it is important to understand the specific definitions and requirements outlined in each edition. The National Electrical Code is updated every 3 years, and each edition may contain revisions and additions. It is crucial to consult the specific edition of the National Electrical Code that is in effect at the time the electrical work is performed. The National Electrical Code is a comprehensive set of rules and regulations designed to ensure the safe installation and operation of electrical systems. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the National Electrical Code is essential to prevent electrical hazards and to ensure the safety of people and property. The authority having jurisdiction, which is typically the local building department or electrical inspector, enforces the National Electrical Code. The authority having jurisdiction has the responsibility of reviewing electrical plans, inspecting electrical installations, and issuing permits. It is important to work closely with the authority having jurisdiction to ensure that all electrical work complies with the National Electrical Code. In addition to the National Electrical Code, there may be local codes and regulations that apply to electrical work. These local codes and regulations may be more stringent than the National Electrical Code. It is important to be aware of and comply with all applicable codes and regulations. When working with electrical systems, it is essential to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It is also important to de-energize electrical circuits before working on them. De-energizing a circuit involves turning off the power at the circuit breaker or fuse box and verifying that the circuit is de-energized with a voltage tester. Never work on live electrical circuits. Electricity can be dangerous and can cause serious injury or death. Always take the necessary precautions to protect yourself and others from electrical hazards. When sizing conductors, it is important to consider the ampacity of the conductor, which is the maximum amount of current that the conductor can carry safely. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. The National Electrical Code provides tables that list the ampacities of various conductors under different conditions. It is important to select a conductor that has an ampacity that is sufficient to carry the load served. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when a circuit is carrying more current than it is designed to handle. Short circuits occur when there is an unintended connection between two conductors. Overcurrent protection devices will trip or blow when an overcurrent condition occurs, interrupting the flow of electricity and preventing damage to the electrical system. Grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip or blow. Grounding also helps to reduce the risk of electric shock. The National Electrical Code requires that all electrical equipment be properly grounded. This includes metal enclosures, conduit, and equipment frames. In a Y system, the neutral point is typically grounded to provide a stable reference point and to facilitate the clearing of ground faults. The neutral conductor carries the unbalanced current in a three-phase system, and it is important to ensure that it is properly sized to handle the maximum unbalanced load. The size of the neutral conductor is typically based on the phase conductors, but it may need to be larger in certain situations, such as when there are significant nonlinear loads present. Nonlinear loads, such as electronic devices and lighting ballast, can generate harmonic currents that flow in the neutral conductor. These harmonic currents can cause the neutral conductor to overheat if it is not properly sized. The National Electrical Code provides guidance on how to size the neutral conductor in systems with nonlinear loads. When installing electrical wiring, it is important to follow the proper wiring methods. The National Electrical Code specifies the types of wiring methods that are permitted for various applications. Wiring methods include conduit, cable, and wireways. The wiring method must be appropriate for the environment in which it is installed. For example, wiring installed in a wet location must be suitable for wet locations. The wiring must also be protected from physical damage. When connecting electrical equipment, it is important to use the proper connectors and fittings. The National Electrical Code specifies the types of connectors and fittings that are permitted for various applications. Connectors and fittings must be properly installed to ensure a secure and reliable connection. Loose or corroded connections can cause overheating and can lead to electrical hazards. Electrical inspections are an important part of the electrical safety process. Electrical inspections are conducted by qualified electrical inspectors who are trained to identify electrical hazards. Electrical inspectors will review electrical plans, inspect electrical installations, and issue permits. It is important to cooperate with electrical inspectors and to correct any deficiencies that they identify. Regular electrical inspections can help to prevent electrical hazards and to ensure the safety of people and property. When troubleshooting electrical problems, it is important to use the proper test equipment. Test equipment includes voltage testers, continuity testers, and ammeters. Voltage testers are used to verify that a circuit is to energize before working on it. Continuity testers are used to check for broken wires or loose connections. Ammeters are used to measure the amount of current flowing in a circuit. It is important to use test equipment safely and to follow the manufacturer's instructions. When replacing electrical equipment, it is important to use the proper replacement parts. The National Electrical Code requires that replacement parts be listed or labeled for the intended use. Listed or labeled parts have been tested and certified by a recognized testing laboratory. Using the proper replacement parts ensures that the electrical equipment will operate safely and reliably. When making electrical repairs, it is important to follow the proper repair procedures. The National Electrical Code provides guidance on how to make electrical repairs safely and effectively. Electrical repairs should be made by qualified individuals who are trained to work on electrical systems. Improper electrical repairs can be dangerous and can lead to electrical hazards. When working with electrical systems, it is important to stay up to date on the latest codes and regulations. The National Electrical Code is updated every 3 years, and each edition may contain revisions and additions. It is important to attend continuing education courses and to read industry publications to stay informed about the latest changes in the electrical industry. Staying informed about the latest codes and regulations will help you to work safely and effectively and to provide your customers with the best possible service. Ultimately, safety is paramount when working with electricity. Always prioritize safety and follow all applicable codes and regulations. Remember, electricity is a powerful force that can be dangerous if not handled properly.